Welcome to our dynamic panel discussion, Agile Architecture for Digital Innovation. I'm Susanna Schwartz, Managing Editor of Pipeline, and today we will have a dynamic panel discussion with some of the industry's experts on what's driving the move toward agility and what needs to happen to infrastructure, management systems, and development approaches as DevOps and microservices emerge to accommodate the rapid changes of the digital economy. We will discuss how service providers and suppliers can pursue the scale and flexibility of web-scale operators using the pillars of agility, which we define as network, orchestration and NFV, AI and analytics. We are joined today by Patrick Kelly, Principal Analyst at Appledore Research, and Danny Johnson, Director of Verizon Enterprise Services Product Marketing, Strategic Enterprise Networks, who will set the stage for our panel, which includes Stephen Frattini, Ericsson's Virtualization Standards Manager, Eric Troop, CTO, Media and Telecommunications at Microsoft, Anand Thumalapalli, Head of Product Development at Jenny, and Lance Uehara, Senior Director of Product Management at Dolly Wireless. Before we get started, we want to encourage you to type in questions in the questions box for the panel to answer during a 15-minute Q&A at the end. Let's begin with Patrick from Appledore. I'll start with you. Let me ask, what do you see as some of the main drivers for agility today?
Okay, thanks, Susanna. There's a few slides I just wanted to present for the audience just to sort of set the stage for today's webinar. This is some material out of our research that was related to the economics of virtualization. There's a few charts I'll just go through. The one on the left that you see is economists like to use the terminology production possibility frontier. And so when you look at that in the context of a service provider, you can look at it very simply in terms of the number of orders that they need to process, instantiate, and support on a long-term life cycle. The other thing is these orders will vary. So the services that get deployed may be very complex services. And so from a perspective around the PPF or the production possibility frontier, the more complex the order, the less orders are fulfilled. So that's effectively what you see with the red curve. What virtualization does, it actually expands the production possibility frontier. And it does that in a number of ways. One is not just simply through the virtualization of the functions that give you scale out capability, but also the management system. So the ability to actually automate a lot of manual tasks, but also feed that back in a closed loop environment so that you're able to predictively look at how a service is performing. And if there's any service impacting events, you can actually drive changes through an orchestration system. And I'll talk about that in a minute or so. The other two charts, again, simply are a reference on how we see the market evolving. So the top right chart essentially is a substitution model, where we are today in terms of the physical network functions and their move towards virtual network functions. So effectively a move from hardware-based appliances to software in the context of things like virtual EPC, virtual CPE. We would even include SD-WAN in that definition. So every technology that we've seen, the last chart, if we look at it from a mobile perspective, they all follow sort of a mathematical substitution rate. And so what we did is we sort of modeled things in terms of Fisher-Price. The key takeaway on this is that the transition from where we are today in most operators' environments to where they'll be in the future is about a 10 to 12-year transition journey. So the next chart I have, which sort of sets us up for our panel discussion, is how do we actually achieve some of the things that I'm talking about that relate to the economics of moving to a hybrid virtualized infrastructure. One of the things that we think is critical is the ability to automate a lot of functions in the service provider's environment today. So if I just sort of frame up where we are today from a management systems perspective, most of the systems that get deployed will manage either separate technology domains. In some cases, they're managing separate services. And all of the workflow processes. So if we look at engineering and planning, operations, activation, fulfillment, they're all fundamentally separate silos. They're separate processes, and there's some sort of manual handoff from one group to another, and the systems are there to sort of try and help do some level of semi-automation. What virtualization and this move towards cloud-based services does is it means that operators are going to need to modify their management systems. And the diagram that I have in front of you is sort of our view of how we see this happening. And there effectively will be a maturity in each of these areas. But in essence, what we see is you will have to have systems on the assurance side and the fulfillment side, as well as engineering and planning, all come together operating in a closed-loop function. The things that need to change is you'll need to be able to process data in real time from many different both technology domains, but in some cases across geographic centers within the operator as well as outside the operator. As that information is pre-processed and analyzed, you can start to automate some of those functions where if you get some sort of service impacting event, the assurance-based systems should be able to trigger through an API into the orchestration systems, which are, again, multi-layer. And you may run it through a policy management system to effectively rearrange the underlying infrastructure. So you may rearrange resources based on capacity demands. If there's some sort of fiber cut or whether you may reallocate links, you may turn up new functions, virtual network functions in different data centers. This is going to require a radical change in the management systems, and at the same time still be able to support some of the legacy services that are in place and to some extent interface with the existing management system. So that's what we're going to talk about today. I'm going to turn it back over to Susanna, and we'll get a perspective from Danny Johnson from Verizon. Thank you.
Thank you, Patrick. So Danny, from a CSP perspective, what does agility mean to Verizon, and what is the relevance to your customers?
So there are a couple dimensions to that question. It's a very good question. And from an agility perspective, solely from a CSP view, what it means is very common to what we're delivering to our enterprise customers. But let me start with the CSP view first. Verizon, we also are a business, and we have a large global operations as well. So as we continue to deploy services internally as well as externally, we have to find new ways to ingest data and as just mentioned, figure out ways to take that data, correlate it in an automated way, and make decisions very rapidly at scale. In addition, we need to also deploy services at scale, within our organization as well. And this is where orchestration then capabilities and virtual functions really come into play. On top of that, we need to ensure that we have a policy engine that we can deploy in an automated way and at scale so that any application we deploy internally as well gets the appropriate level of treatment, especially as we begin to move more applications to cloud-based scenarios as well as through the mobile community. Now, as we continue that transformation internally, what that does for us is to be able to enable those same transformation and virtual technologies to our enterprise clients. And some of the critical challenges we're seeing really in the enterprise space, just to touch on a couple of them, there are several, are, as an example, retail site transformation. And we see customers that are looking for ways to optimize and increase location store sales, in addition to providing quick and simple customer engagement models. As mentioned before, the data explosion continues at a very rapid pace. Speed to revenue, as well as improving the customer's experience, are also a couple other areas where we're seeing our customers really being challenged to continue to not only drive the results for their shareholders, but then also ensure that they stay competitive in the marketplace. So being able to provide secure and flexible automated standardization deployments within their own operation becomes very much a cost enabler, as well as a very agile means to deploy services very quickly. So think about traditionally being able to deploy services where in months, they can now do that in days, just to name a few.
Thank you, Danny. And I would like to pose to the panel the question of what is agility and how would you define agility, and how does it apply not only to virtualized function, but all the apps and digital services riding on top of the network being one of the first pillar of agility we're going to discuss. So does anyone on the panel want to take that question?
Yeah, hi, Susanna. This is Steve Frattini. And I think the network agility is really an end-to-end process, starting from the design phase. A lot of service providers are looking to get, in addition to their own staff, third parties building applications in their ecosystem, and that requires visibility in a standardized catalog of the available capabilities, so that the application and service builders can make use of that information and build services on top of that. In addition to just having the catalog, the analytics are also important. There may be multiple services like firewalls or load balancers in a given ecosystem, and they may perform differently. So having analytics available to the service designer is useful. That can guide their decision to choose one component over another. That's just a design phase. Then a pain point for the service providers is the onboarding. Once you have a service designed and ready to go, there's additional information beyond just what the service designer or the supplier provides to the service provider, and that includes things like pricing information and testing information, and that's being worked in the standards right now. It's quite an issue, and it does require the ability to move quickly. You don't want to, Danny mentioned earlier, you don't want to take months to get your services onboarded. So that's a critical issue. Then during the lifetime itself of the services and the VNF and the services built on top of those, there's a lot of automation that we're looking to see through the virtualization. Things like auto scaling, which is commonly discussed, where the capacity of the service can be adjusted through different policies, not just for the service itself, but also based on the current state of the network. And then there's control loops for auto hailing, auto migration for mobility services, where maybe a customer has a set of services and they want to have at least a subset of those in place when they move from one area to another. So there's auto moving of some of the components in order to ensure proper latency. And again, all throughout, you need to have good analytics so that you can auto correct and scale and so forth. So that's kind of, as I say, an end-to-end set of capabilities that you need to ensure network agility.
How about Eric from Microsoft? Do you want to talk a little bit about, in terms of the architecture, how you implement just-in-time resources or facilitate the move to infrastructure as a service or platform as a service or serverless computing with containers?
Certainly. Working and listening to what Steve Frattini was saying, one of the things we've looked at to enable agility in the network is to look at the architecture that we're dealing with. And one of the key principles that we've learned about is to separate and sort of abstract the tenant layer from the platform layer and deal with each of the issues that Steve was talking about separately. Some are definitely at the tenant layer, like something running on top of a platform like a cloud platform, and some things are increasingly being done by the platform itself. So when we look at a tenant function that could be some sort of network function that's been virtualized, it's being service chained to other things, there's an orchestration that happens at the tenant layer. This is something that ONAP is is addressing. But the tenant layer can then ask the platform for intent-based provisioning. So it can define what it wants or the performance parameters that it wants the platform to deliver, and then the platform increasingly, in a closed-loop automated fashion, heavily driven today by data analytics and artificial intelligence, automatically can provide just-in-time resources in a very elastic manner to deliver the performance that's needed. And so the network itself is being implemented in terms of a cloud platform that's very dynamic in its ability to manage resources. And so many of the things that Steve was talking about can be implemented a little bit more easily if you think of what needs to happen at the tenant layer and orchestration at the tenant layer versus orchestration at the platform layer, which itself is heavily software defined. So by separating the two and allowing the lower platform to do what it does in a highly automated, efficient fashion, we can avoid some of the complexities that the industry has been wrestling with by having this separation of concerns and allowing the highly cloudified environment of the software-defined data center that's hosting these virtualized network functions to do its job in a very efficient manner that includes moving towards platform as a service or completely serverless computing or the use of containers. And also at that level, if you write your virtualized network functions to a PaaS layer, then you actually achieve portability across clouds, because all the software developer has to do is pick one of these container technologies, and then the operator has the freedom to deploy that containerized technology or that containerized virtualized network function, deploy it across any cloud platform which supports that container technology. And that actually gives a great deal of agility and flexibility in how and where things are deployed.
And I think that's such a great point, Eric, that brings up. And I think there's a direct client benefit that we're seeing here as well, because what we're seeing is the genesis that started in the cloud environment, the compute environment for on-demand services, has now made its way into the network. It's essentially kind of cloudifying the telco environment, where we're seeing that now enterprises can really consume services and microservices in a very flexible fashion. So what I mean by that, is take an example, security services or application optimization services or SDN-based services. The traditional means of consuming those services would be, on a term type of contract. You have to engineer those services separately, and now you can actually deploy those services in a virtual environment on demand, service chain within that environment, and you can consume those services on a pay-as-you-go kind of commercial utility model, which we're finding is very, very appealing to the enterprise marketplace today. So there's a pretty compelling enabler, that Eric speaks about, as well as Steve, in terms of the network agility capabilities that then can manifest into just pure client benefit.
Hi, Susanna. This is Anand from Jenny. It's a good cue in terms of the state of what service providers like Verizon, Danny mentioned, and also Steve from a standard standpoint. One of the things we see often is change is key. For making sure the service is up, you have to monitor change, and big data comes into play big time here. We look at a simple network of small cells as an example, where it uses a cloud RAN and trying to set up its network by itself in a virtualized way using some sort of a hybrid SON. And when you need to do that, there's a tremendous amount of configuration which needs to be set up. And a lot of that comes from assurance systems which are monitoring change and looking at whether it is network change or configuration change. And those systems further looking at like chat ops, which are looking at whether it's network, machine, or user-generated data. It adds a tremendous value to understand what's happening to the service, and whether it is virtualized or hybrid. Make sure that you can understand the impact of that change. Because in the short term, while we need to roll these services out, the service uptime and the quality of that is more important to get the adoption going. So we see a tremendous opportunity for looking at that and trying to log all this data so that you can apply analytics like Steve was mentioning, and so was Patrick actually, from an assurance standpoint. If you don't do that, you're going to run into a situation where you don't understand your fairly complex service definition which you have today to enable that service across both a traditional network elements and virtualized network elements actually.
Okay, this is Lance from Dolly Wireless, and continue with that in terms of this end-to-end agility and the end-to-end network importance. The RAN part, the radio access network part of this will become very critical in terms of these agile networks, and particularly because historically the air link, if you will, the radio part has always been the bottleneck of these networks. You can get much higher bandwidth over the wired portion than you could over the wireless. And it boils down to the amount of bits per hertz that we can get over that air link. And in terms of this, evolving the network, it's this densification that these operators are using now to increase that in terms of getting better use of the spectrum per area. Okay, and there's several tools that we've used in the past in terms of using higher order of modulations, 64 QAM to 256 QAM, or different antenna technologies like MIMO as a way to get more bits per symbol. But really, it's the densification of cells that have been more, more common with these operators nowadays in terms of driving better efficiency in their network. And towards that end, it was this growth of small cells that more recently we've been using to densify the network. The issue with that is in 3G and 4G, it was fine with these small cells, but they are hardware-specific platforms. They're system-on-a-chip based usually. There's limited capacity per small cell, and more importantly, limited capacity per antenna location. And they're not easily reconfigurable. And this is where the virtualization of the RAN will really benefit this in terms of agile networks. By centralizing or creating these virtual RANs running on x86 servers, it allows us to get this processing power of a macro network, if you will, in a server, but then deliver it to radio points that could be served by low power radios, which would be the next evolution of a small cell. So it's essentially getting the densification, but then getting the capacity performance of what you would expect normally today in a macro cell. And that's what will enable these flexible platforms and be able to get, for example, location-specific delivery of signals, right? Because in a small cell with densification, you can get very precision-delivered signals to a small area. We can then handle high bandwidth or high bandwidth, low latency types of applications. For example, video processing or augmented reality, where you need a lot of bandwidth for certain applications, or mission-critical low-latency applications like a real-time control for autonomous vehicles or airborne drones, where we need to move some processing out more to the edge in terms of mobile edge computing, for example. And so that's why going forward, we see the RAN being very important in terms of providing an end-to-end type of agile solution.
Thank you, Lance. I'd like to now move on to the next pillar of orchestration as a means of managing the complexity of networks. So I'd like to ask the panel, what are the key issues around orchestration for CSPs and their suppliers today?
Okay. Yes, Susanna. So one of the things that I want to cover off, one of the terminologies is being bantered about in the industry right now is intent-based modeling. Some of that's in the context of the challenges around multiple VNFs being deployed in the service provider's environment. So I'll talk about that a little bit. And I think one of the issues that I see in the marketplace that service providers are sort of struggling with, and in some cases that sort of is an indicator to how fast the market actually moves. So the investment cycle that should occur and the maturity of deployments that we see in the marketplace. So there's really three things that I see. One is you have the NFVI, if you will, layer, and that's the deployment. It could be OpenStack, could be Azure, it could be a VMware type deployment. And then you're going to start to instantiate DNFs, which will come from incumbent suppliers, but increasingly newer suppliers that are making their way into the marketplace. And the third component of that is you have the Mano stack. So you have the orchestrator, you have some sort of topology graph. Anand was talking about the analytics capability. So you have to manage all this. And the fundamental problem that I think that's really tying up most service providers that are getting wrapped around the axle is the fact that they need to be able to test, validate, and certify in their operational environment how the services are going to perform. So, how well can you actually turn these services up, service chaining and the instantiation? How well will they perform after, in a mixed environment, mixed multi-vendor environment, once you've actually set that service up? I think, right now we're sort of in an environment where there's a lot of what I'll call fat DNFs that are being deployed. The management systems haven't really been fully matured in the operator's environment. And so that, it's a fundamental challenge. So, going forward, as we look to a cloud-native deployment, and I think Eric, can comment on this, you can potentially have thousands of configurations or parameters of microservices. So this area is something that is still being addressed, both from the supplier's point of view, and it's something that, until we get some sort of resolution here in this mixed multi-vendor environment, it's hard to sort of move things forward because the cycle times are so long. So for Verizon, you could be looking at cycle times to instantiate a new service in this three-tiered environment that might take 6 weeks or longer to get that comfort level around certification. And I think where we need to be moving is how do we shrink 6 weeks of onboarding into a few days? And I think that's one of the fundamental issues the industry is grappling with.
If I could comment here at this point, this takes us right into a DevOps perspective. So one of the things we've discovered, or some of our tier one operators that are part of the ONAP program have discovered, is that one way to address this problem appears to be to allow a virtualized network function vendor who's building something to just build it, hopefully using a cloud-aware type of software architecture. Let's say, for example, Cloudify as an example, or Kubernetes. But I'll start with Cloudify because they're part of the ONAP project. So if they actually just build their software in a cloud-aware context and deploy it on a platform like Azure, which supports Cloudify, then they can actually just do all the dev tests and make sure it meets the typical service provider's requirements, which the vendors are pretty familiar with anyway. And then that product, it sits there and it can be actually just go into a marketplace, a cloud marketplace. One of the issues is that the BSS OSS of the typical operator is not really organized around managing cloud resources. So you can actually just build it in a PaaS portability layer like Cloudify, put it in the Azure marketplace, and onboarding is effectively done because a marketplace like that has all of the commercial terms and conditions wrapped around it automatically. And then you can just, an operator can then just consume from that cloud marketplace, and that thing, that entity, spin it up, decide where they're going to deploy it in the overall network, and then configure it and do their service chaining. Some of which could be today could be swivel chair type stuff, but nonetheless extremely quick because all the onboarding stuff has already been done. So this is the new kind of thinking that people are becoming aware of as you separate what's happening at, as I described, the tenant layer, which is where ONAP lives, and then what the cloud platforms themselves can do to simplify some of these tasks and thereby gain agility. Now, if the virtualized network function vendor does what I described, they can also then just apply DevOps to that and begin to do continuous improvement to that service offering that's sitting in, say, built to cloudify architecture, but sitting in a cloud marketplace. And of course, the operator could choose to redeploy that to any other cloud platform because, again, the PaaS layer, this type of approach, gives you portability across multiple platforms, any platform that would support, say, Cloudify or Kubernetes, whatever software architecture was chosen. So this is a pretty quick way to move forward and resolve some of these technical architecture issues and operational issues that the industry has been experiencing thus far.
I think the fundamental aspects of just some of the CSP challenges that have been discussed are definitely spot on. And I know, so one of the things that Verizon continues to do and is doing is really establishing up front, and we're leveraging a mix of, the standards that are already defined, the templates that are already defined there in the market, in the marketplace today. In addition to kind of having to modify some of those and working very closely with vendors to do two things. One is on the onboarding side from a CSP perspective, right? It's definitely can be a challenge, to kind of create an automated, very agile framework to onboard vendors. But this is something we're definitely working on right now, leveraging what's available in terms of open standards, and then, as I mentioned, kind of modifying some of those for fit for purpose for us. So in essence, kind of creating this vendor community, by which we can onboard. And then not only just onboard, when we take the mixture of service chain microservices, certifying those well in advance. So we go through a certification process, and then what that does is once we're ready to take it to the marketplace for the enterprise clients, it becomes very easy then to deploy those services because the vendors have been onboarded, the microservices have been already validated and certified to be able to be automated in a service chain environment. Now we can deploy those microservices, in a very compelling commercial model, as I spoke about a little bit earlier. So we're still moving across the maturity path. But there are many aspects of what's available today that are enabling us to be able to kind of bring something to market now.
Okay, thank you. And Steve from Ericsson, do you have anything you want to add before you close up this section?
Yes, thanks, Susanna. I agree with the previous speakers, and I think this kind of leads into where we're going with the VNFs and NFV and SDN also. Right now we're kind of in the sort of a middle phase where we had some really good goals that are in the process of being fulfilled in terms of virtualizing the network appliances and allowing for the use of commercial IT platforms where you can put multiple services on the same platform as opposed to where you had physical network appliances that were kind of dedicated to a given hardware platform. This is a good cost-saving effort, and as the previous speakers mentioned, there's some significant issues that are being worked right now in terms of onboarding and moving quickly. But I think the end goal needs to get beyond just the network appliances. We need to look at the services that are built on top of those to support different industries. Big companies like Verizon, have customers at smart city, energy, banks, and so forth. And those services are sort of the next wave. The good news there is that's where you actually are increasing revenue as opposed to saving money at cost. So some of the problems we're trying to solve now in terms of onboarding hopefully will make it a little bit easier for the higher level services that'll be supported above the NFV and SDN infrastructure.
Thank you, Steve. And I'd like to just close this section out by asking Danny a question about that next wave of services that you mentioned. Danny, do you have any thoughts on what some of those services might be or where you're headed, what direction you're moving in?
Yeah, so the next wave of services really it's really endless. Some of the things though that are immediately on the horizon. You think about 5G enabled services, right? That is a very obvious one, definitely on the horizon as well. You think about IoT. So IoT-based solutions, so smart city solutions, fleet management solutions as well, become very, very compelling and preeminent to bring into this particular ecosystem as well. You think about other solutions pertaining to things like blockchain, right? And I think this is the criticality on once you establish kind of some of these parameters, the baseline on the platform, the orchestrated environment, the automation behind it, the learning, the not only just AI, but machine learning, being able to ingest all those elements to be able to consume, onboard, and then enable enterprise customers to consume those services across a single orchestrated platform and management and policy environment, then becomes a very compelling value proposition. So those are just a few, that I think that are very real in terms of just what's on the horizon. And once we can kind of land on the platform elements, adding, as Steve mentioned, these other microservices becomes a very profitable value proposition for our clients.
Thank you, Danny. I would like to now move on to the third pillar, which was leveraging data, AI, and analytics. And, we've talked a lot about the complexity of the networks and how orchestration can help. And I wanted to talk a little bit about dynamic topology and how to manage SDN networks and NFV and the struggle to understand topology as it evolves.
Hi, Susanna. This is Anand from Jenny. Let me add a little bit there from that topic. Agile lifecycle management, when you look at a fairly hybrid network and services being enabled on top of that, you need a service model well established, which a lot of people do for orchestration for enabling new service. But we look at it from different perspective that the service models are well created and they're typically work on enabling the service but not necessarily decommissioning the service itself. And this is where topology requirements come into picture, and it needs to be fairly dynamic and fairly real time in nature. And reason being is, like, if you look at the operations side, when you're getting a fairly large number of events from the network, or whether it's virtualized or physical network elements, is a tremendous challenge in actually trying to understand what's important and what's not important, and to and do the analytics on top of that to say that what are the related events and how do you group them together. So when we look at that, analytics play a big role in the operational side of the house. And further, if I take that and say, we were talking earlier about introducing change. When a change happens, the dynamic topology solution should support so that you can play back and see. And when I say playback, not necessarily using humans, but actually a correlation engine or a engine which is doing analytics across to understand, so that it can understand what is causing the impact actually on the service itself. So there's a strong need for CSPs to actually look at that. And then the next layer is the presentation layer, right? There's a lot of information coming across to the NOC and the other users. The general tendency is that, I have to look at multiple screens to get to it. Unification of that is important. Unification of that in a very light manner so that it's not necessarily causing hindrance to actually the effectiveness of that individual to take action. And so integrating into chat ops kind of platforms, there's quite a few out there easily, so that you can build the entire knowledge and capture the knowledge into the knowledge base across the teams. And as a result, you can leverage that further for reducing service impacting situations, and using, analytics is key there. So we see a big trend there. We see that, customers wanting to capture what they call as, hey, I want to do logging or centralized logging. I want to log network changes. I want to log, config changes. I want to log, anything user-generated data, which enables them to do analytics across all sources of data, which is being reported back, and that lays a foundation for a good operational, system from an OSS standpoint.
Yeah, I could add Eric Tripp again from Microsoft. So this concept of dynamic resource allocation is extremely important. It's the only way you get close to the business value that was originally anticipated in the 2013 edition of the NFV white paper. So the cloud, when we say leveraging the flexibility and scalability of the web-based service providers, this is a key ingredient, is totally AI-driven, heavy data analytics-driven assignment of resources, scaling out and in, not just scaling up, but scaling out and in automatically based on the analysis of a workload. So we talk a lot about intent-based provisioning, where, again, the tenant system says, hey, these are the performance criteria, the performance envelope that I'd like you to support. And then the cloud just does it. But it's done through intent-based provisioning, and we're actually reaching a point now where we're talking about predictive intent, anticipating through the AI and analytics and the state engine, the inference engines, what the next set of resources need to be, or what the configuration of the network resources need to be. And remember, in this environment, we're just talking about moving IP packets, but everything is moved over completely virtualized IP addresses that have to span not just one service provider environment, but ultimately might have to span 2 or 3 different service provider environments. So the challenge is, how do we manage that end to end? We don't want to just route packets over the top as a best effort to a 5G attached device. We actually want to have this kind of dynamic allocation of resource extend all the way from the hyperscale cloud out through a co-location point, through somebody else's core network, maybe 2 people's core network, and then eventually all the way out to the 5G edge, including the radio frequency optimization for the use case. Because as you know, in IoT and 5G, we use the correct type of technology, whether 300 gigahertz or 60 megahertz. We use it for the specific IoT scenario we're trying to support. Cars talking to each other going down the highway and talking to the network, dense urban or sparsely populated rural. Again, all of these things play into all these IoT scenarios we're trying to support, and we need the industry needs end-to-end quality of service and just-in-time resource provisioning, including things like 5G resource allocation, slicing is the word I was looking for, in order to support that. So this is we want to take that from the hyperscale cloud, where we kind of know how to do a lot of that, and extend it beyond the perimeter of that cloud all the way across these other service providers, all the way to the edge. And that's the current industry challenge, how to do that.
Yeah, this is Lance from Dolly Wireless, and continuing on that concept that Eric was talking about these end-to-end, complete slicing to provide these, I guess, application or service specific type of services or network configurations. Key to that will be network slicing, creating, again, this end-to-end specific configuration, if you will, of the network for whatever a service or application is running. It needs to be seamless, basically from the services on down to the platform. One of the key challenges were, in the past, we had this one-to-one correspondence between the base station resources in the radio access network and the radio heads, the actual radios. And going forward, we're going to be needing these multi-point type of radio networks where it doesn't matter what radio we have out there, where it's located. We need to deliver those signals to those radios. And by having these network slices all the way through the network and getting down to the specific radio even that we need, to specific channels, specific type of modulation, that's going to be critical to making these networks work very efficiently. For example, in the enterprise market, for example, what's becoming very critical nowadays is, with people bringing their own device, for example, is the need for even a multi-operator type of network, where you may have your employees on one operator, but your visitors or clients may have other operators. So, the ability even to create these slices for different operators, for example, will be critical in these types of radio access networks. Also, multiple bands, for example, will need to be supported. Whether there be carrier aggregation or not, or they're using a higher frequency band that has more capacity. Having a network that's agile enough to be able to switch to multiple bands, whatever they may be, and deliver that signals to the user will be critical. And that's sort of how we see this dynamic topology and the dynamic of the network.
Yeah, those are all really good points. You go from the application stack to the topology of the network and the dynamic capabilities there. One other component that really then would be required is you need end-to-end visibility across all these disparate architectures. And I think that's where kind of the single orchestrated platform comes into play. I know Verizon's been working very closely with Ericsson, in establishing some of these, and we actually already have established some of these together. But there are a few other dimensions, I think, that are meaningful here as well. You have the self-healing capabilities, on the dynamic side, of the network. This requires a very robust set of data and a very robust means to consume that data and make intelligent decisions, especially in the cloud. So if there are anomalies that are taking place, when customers are consuming microservices, how do we identify those and make a decision automatically to move those services somewhere else so that the customer's SLAs are not impacted? That's dimension number one. The other dimension number two, pertains to deeper application insights, right? So when you think about applications now that are really traversing any platform, being able to have insights into those applications, right? So was a transaction, as an example, actually made, on a financial broker platform? Was it completed? Did it meet its intended result? What's the SLA that was tied behind it? When you're able to infuse those insights, into an overall platform environment or orchestrated environment, that becomes very meaningful, because what we're able to do now is not offer services based on an application. Now we as a CSP can offer services to our clients based on their business goals, their business outcomes, an SLA-based type of service that we can deliver to them. And then lastly, the analytics really across complex platforms. This becomes a very compelling notion. So think about on the network side, you have a lot of data that may be reflected in a NetFlow stream. On the security side, you may have a lot of data that is reflected on a syslog stream. Then you have a lot of the cloud-based workloads and the analytics that come into play from that environment. Imagine where you can infuse all of those different elements, into a single environment and make intelligent decisions that really can support self-healing capabilities, as I mentioned before, that can really begin to make simplify very complex decision sets based on a lot of data in all of these critical areas, where a customer now can identify, a customer environment can identify, as an example, a DDoS attack, and automatically auto-configure and spin up containers and images to mitigate those attacks. That becomes very compelling for our customers as well. And we're finding as we speak to our customers, that becomes a very interesting and very meaningful means, for them to be able to kind of infuse massive levels of agility within their own operations, and for us to be able to deliver it that way.
Thank you, Danny. And I did have a follow-up question, and then we can get to the Q&A. When it comes to this level of automation and auto configuration that we're talking about, what is the time frame we're talking about when these things really become a reality in terms of the hype cycle to reality?
Well, I'll start with the hyperscale cloud. From a Microsoft perspective, it's all there today. So this type of analytics and this type of dynamic assignment of resources is very current today. So, but that's only a third of the problem. The rest of it is how do we coordinate, or how do we do that in the rest of the network out to the 5G edge? And 5G, of course, we're just at the very beginning of deployment. A lot of the technology isn't all there. So how do we extend it all the way out to the edge? Is the rest of the story. I think that's the key point to this. And if I have an end-to-end service, how do I get that end-to-end QoS? I might be able to manage things effectively on 1/3 of the infrastructure, but the other pieces, to say to us for not running an IoT app, it's effectively unmanaged because there's no current way for, say, ONAP, an application server in my environment to ask ONAP to ask another service provider to give me just, a network slice to handle a specific set of requirements. There's no effective way to do that today.
Okay, thank you. Does anyone else have anything to add before we go to the Q&A?
Yeah, I mean, we are deploying, orchestrated services, in x86 as well as, cloud-based environments today. So the reality and the promise of what SDN and NFV-based technologies have intended to bring to bear, is alive. So this sets the stage, for us to begin to infuse and ingest everything that we talked about in terms of just the 5G integration, the application-aware learning, being able to deliver services, on a business outcome base, So, that's not something that's pie in the sky now. There are real deployments, that are taking place today.
Thank you, Danny, and I appreciate the panel taking the time to explain their points of view on all these topics. I'm going to now open the discussion to Q&A from the audience. Thank you, everybody. Okay, so we're going to open our Q&A. We have a question from an audience member about what Verizon and Ericsson talked about in terms of the challenges of SDN NFV. Perhaps Eric Troop of Microsoft can summarize what are a couple of key challenges that remain so that CSPs can move from an OpEx reduction initiative to revenue-generating initiatives. So, Eric, maybe you can start.
Well, I think that gets to the essence of the digital transformation. So, part of the original goal was to become less hardware constrained, more software defined, and the industry spent a lot of time trying to define a cloud architecture that was mostly infrastructure as a service focused, and that process created virtual functions and so on and software that was kind of oriented toward an infrastructure as a service cloud, and it delayed the ability to focus on making brand new services and gaining the agility to launch brand new services that are more software defined and more oriented towards revenue generation. So I think part of the problem in the question was, why is the adoption seen as so slow? Is one, we spent an awful lot of time trying to sort of redo the cloud and focus on infrastructure as a service, and I think that actually slowed down the development of new types of services that could work in the newer environment. That's where that's where we get to the agility. Of course, telcos have always had some difficulty. Having come out of Verizon myself, we've always had some difficulty transitioning from core services to brand new services. So one of the big efforts in that area is, of course, gaining access to content, delivering content, and monetizing various kinds of content, and that requires in essence, a mature cloud platform that can take these types of content and the streaming of content and deliver it all the way out to the end. So I think the delay has been two-part. One, trying to reinvent the cloud for a long period of time, and then 2, understanding how to transition from these revenue-producing services that are really tenants to this new environment that's not fully done yet, and understanding how to play in the content delivery business and generate revenue in that context rather than through lower-level connectivity services or roaming charges.
Thank you. I would like to follow up on that. Maybe Danny from Verizon could talk about the key benefits to your clients in terms of new services that come out of these types of initiatives.
Yeah, sure. And so some of the things that we're seeing really then in terms of what our clients are looking for and kind of perhaps what challenges they're looking to bring to bear. And it's really kind of a tale of traditional kind of versus new models. So as an example, where some of our clients are kind of nodding their head north and south, an agreement in terms of just understanding is today you have some pretty rigid monthly billing environments, and it's vendor-based. And so when you think about moving then to kind of some rigid billing environments to flexible monthly billing environments, that then becomes very compelling, for our clients, because now, they're not locked in, from a financial perspective. Additionally, there's a scalability element here. So a la carte pricing, right, versus at a microservices level versus an all or no feature. So clients are typically signing 1, 2, 3-year deals and contracts, with application providers, software providers, and they're locked into the full feature set. Whereas now in a virtualized environment, you can kind of pay for what you need during the time you need them. That could be a subset of micro features within a security environment, as an example, or a routing environment, or an SDN environment. Thirdly, there's a pay-as-you-grow element here, a lower cost entry point, from a pricing perspective, and then clients can really upgrade as they need. What this does is really ease the burden on large initial CapEx investments, and then lastly, being able to kind of aggregate and simplify a complex and disaggregated environment. So think about the variety of vendors that a client may have to deal with and engineer for. Now, really bringing all those in within an aggregated platform with simplified deployment models that are virtualized, we've seen has become a very compelling value proposition for our clients today.
Okay, thank you. I do have a question here for Appledoor's Patrick Kelly about how AI is showing promise in its ability to manage a distributed architecture. Where are gains being made today in machine learning in the AI market?
Thanks, Suzanne. I'll just give a quick recap, just given the time. So one of the things that we're seeing that operators are focused on are specific areas of their infrastructure. So if you look at where we're actually seeing some progress in the marketplace, it's in the RAN, particularly with deployment of SON-based technology. Also SDN. So if you look at what's happening in the SD-WAN environment and the deployment of SDN in the infrastructure, you're seeing this agility. You're seeing much more automated capabilities that are being brought into the operator's environment. I think one of the issues that, this goes back to the earlier question, where things are slowing a bit, is in the NFV domain. We do see some operators experimenting. If you go back to the earthquake disaster in Japan in 2011, some of the mandates put forward by the government was to effectively move towards a distributed architecture, and that was to avoid, both the impact of the earthquake, but also, the meltdown that we saw in Fukushima power plant. And it's these types of events that I think sort of move the industry forward. But using more sophisticated capabilities in the machine learning and the AI area, I think will advance things in the right direction, particularly across some of these different technology domains. So Danny pointed out, services just don't run over one part of the infrastructure for Verizon. They actually touch many different parts of Verizon's infrastructure, and so I think that's where the industry is moving is if you will, threading together different capabilities that a service can provide over these different architectures, and then I think the right approach is to focus on automation at the subdomain level.
Okay, thank you. And I think, Anand from Jenny, maybe you want to add something about the AI and machine learning piece of this?
Yeah, thanks, Susanna. This is Anand from Jenny. We see analytics playing a big role in operations in this hybrid environment. It creates a foundation for patterns to be established. It's very tough to understand such a complex network, with NFV and SDN. And even in the small cells examples where, you have over 300 odd RAN parameters being set up in a hybrid SON environment, So here where we see is the learnings happen with analytics, and then that's the machine learning piece of it. And once you have those learnings, how do you apply this so that there's no human correlation? And we see AI playing a big role there. And this is really resulting in a significant amount of reduction in events being presented to a NOC operator, who's sitting in front of a screen and looking at a very large volume of data coming in. And we've seen in examples where operators are able to do a reduction of over 90% of the events being present, and that results in a huge OpEx benefit, actually. Thanks.
Okay, and I did have one more question for Dolly. Lance, if you could tell us about the likelihood of Open RAN that came in.
Okay, sure. Yeah, as far as Open RAN, the prospects look very good from an industry-wide perspective. We have organizations such as a Facebook TIP or, more recently, the XRAN organizations that are actually heavily promoting now the Open RAN. And the difference is now you have the operators actively engaged. Many of these operators are participating in these organizations, but more so, internally, they each have their own Open RAN initiatives. So from that perspective, looking out, in the next few years, it's definitely more likely anyway that an Open RAN will come to fruition just because of the more engagement, I would say, from the operators themselves.
Great, thank you. We are going to wrap this up. I want to thank all of our speakers and everyone who attended today. And I just want to make a note that this recording will become available online at the close of this session. And if anyone listening in has follow-up questions for any of our presenters, please feel free to contact us. Thank you, everybody.